Well, welcome everyone. Thank you for joining the talk. This is a Zephyr user story. It's about my experience with Zephyr in a couple of the last years. And yeah, shall we begin? My journey begins at ProGlove at the beginning of 2015. And I joined there as an early employee. What does ProGlove do? They develop scanner gloves for the industry. In the industry, for example, in manufacturing, you're scanning a lot of barcodes, and for example, assembling a car, you scan parts very often. And what ProGlove does with the hand scanner is it saves a lot of time in industry, and that's what I developed with them. So we prototyped a lot, and the requirements that we had were mostly came mostly from a product. So it's sub-gigahertz, because in industry you cannot use 2.4 gigahertz, especially Bluetooth. It's a small form factor, as you see, because we want to fit the scanner on the back of the hand. And it has to be, of course, low power. And with a scanner engine that takes a lot of power, that's very hard to achieve. So a lot of you need a big battery in there. So what we did in the beginning, of course, were probably the very same mistakes that everybody does. It was my first job. So we started off bare metal. That's something that came out because we were prototyping a lot in the beginning. Of course, not with the same hardware we later on developed. So the product initially, when we made the switch from prototypes to the actual hardware that we were going to use, we just started with bare metal because we didn't know any better, and we prototyped as we went. And requirements came in every so often. With every new customer visit, you knew you had a new requirement, a new feature you needed to develop, and it grew very, very organically. And as I already mentioned, the hardware components were very heavily dictated by the product itself. I mean, it had to have a scanner engine that needs a lot of energy, and a big battery, and a radio module because it needed to be wireless. So there was actually a second device, which I forgot to mention. The scanner, of course, sends the data to a receiver, and the receiver is connected to a terminal where the data gets funneled in either through keyboard input or a serial connection. Due to time pressure, of course, we made the prototypes later on the product, which led to a lot of work, and what we've built ourselves. We even built ourselves the build system, for example, or a serializer protocol, or especially the UX. So as I mentioned, every feature that a new customer requested, we just built in there because it just was step by step, and there was no real border where we said, okay, this is not a product, this was the prototype, that's the product, and we do everything new again. No, because you reuse everything you have. So at some point, when we already had a couple of devices in the field, we decided, okay, let's overhaul the hardware a little bit, let's overhaul the software. And there we continued, we decided to port everything to Zephyr. And Zephyr, first and foremost, provided us with a streamlined and unified tool chain, which was a pain back then when we did everything bare metal, right? So what Zephyr had there, you just download the SDK and you're done. That's it. You have the compiler, you have the tool chain, you have everything that you need to get the project running with 2 downloads, the repository and the tool chain. That's it. What does it help you? It of course makes onboarding also easier, which in startups happens from time to time because you don't have everyone involved in the project from the beginning. So especially documentation helps there, because in a startup sometimes you don't have the time to document everything, right? So it helps to have with essential component using something that's already documented. Of course, using Zephyr, it made the hardware and the software, the product by itself, adaptable for future hardware improvements. So we tried, of course, then to have abstraction layers and move away from bare metal to a more scalable architecture, if you want to say that. And of course, it made board support maintenance a lot easier, because Board support is very well structured in Zephyr, and it's not like with the bare metal version, sometimes you have driver files for some arbitrary sensor lying around in a source directory, which is should actually be buried in some layer, and you don't want to actually see that as an application developer, right? So what was the timeline? We shipped the first product, so the first iteration, the bare metal version, within 12 months, with mostly myself. And I onboarded one developer during the time into the product, into development, and later on the Zephyr version we had we made it in 9 months of time, so that already accelerated. Even though we onboarded another 2 developers and 2 interns during that time, where the strength, of course, was the heavy documentation side that Zephyr had and still has, that helps us just to tell someone, okay, look into the documentation, everything's there, this is the APIs we use, and you can go and develop something for the application. Why do you actually need more developers if you ship the first product within 12 months? Why do you need more developers later? Well, as I said, the product grew organically, and of course you have devices in the field, so you need to maintain that. So there's bug fixing, testing, on-site customer visits, because at the time at ProGlove it was very important that also engineers went to the customer. So you don't have 100% time to really develop something, but there's lots of different tasks, and it's not only the features you want to develop, but there's a lot around that. And yeah, essentially it's maintaining a technical debt at some point with a bare metal application. That's why we needed more people, and of course also porting that to Zephyr. This took then overall roughly 2.5 years from when I joined developing the prototypes and the product up until we actually CE certified the second product, which we then also shipped. My next journey was at Blik. So in Q4 2017, I joined Blik as lead developer and team lead for their hardware. And what does Blik do? Blik develops a logistics tracking software. So customers come to us and ask us whether we can track their load carriers and or whether we can tell them where their load carriers are. So for that, we have a front end that tells the customer where these load carriers are. So special load carriers, for everyone who is not familiar with that, is so for example in manufacturing, car manufacturing, like car doors or truck axles, these are transported on special load carriers. So these are actually specific to this one part, and these can go in circles. So they go from the manufacturer to their customer and come back. So every time you produce something, you need these load carriers, otherwise you cannot ship to your customer. These things sometimes get lost, sometimes they pile up at one of the parties. So yeah, that's what we're trying to solve, and or actually currently already solving for some customers. And we need hardware for that, and that's my job. So we have a receiver unit that's in point of interest areas at the customer, and a sensor unit that's attached to the load carrier. So that's the hardware we develop, and the Zephyr for us is running on the sensor node. So the requirements there are pretty similar to what I personally experienced at ProGlove. So with the sensor unit we need low power heavily, so these devices need to be in the field for years. Essentially we want to be able to support the life cycle of one load carrier, which can be up to 10 years, for example. From a radio perspective, we are using 2.4 gigahertz, but in 802.15.4, so we don't have any compliance issues with Bluetooth there, for example, in automotive industry. So this time, since this was a new project, I started from scratch. We decided on, and I heavily voted for that we use Zephyr from the beginning, which was a very good decision from my point of view now. And it enabled us to go from prototype to CE within 6 months. To be fair, with a simple application, but it still shows for me that you can go very fast from a very early prototype to actually CE compliance, which we're doing actually at the moment. So lessons learned from my experience. at these companies. So now, within these 4 years, we shipped industry-grade products with small teams and startups. And at first where I worked, it didn't really scale, right? So bare metal doesn't scale. You're reinventing the wheel all the time. You don't want that. So that just doesn't work. We ported to Zephyr, so at the time we ported just too many legacy dependencies still. Like you don't want to depend on your old bare metal organic code. Really try to get rid of that and convert your customers to that, because that's actually the only thing that's necessary, is get your customers to adapt the new product. Otherwise, you're going to, in development, always be dependent on these old interfaces and libraries you developed for you internally. And also, we actually did not upstream enough code. Like, we had a lot of customizations in the kernel, which from some point of view might make sense because you want to build a custom project. Some things might not fit your device, but it's very important to just upstream that, because sooner or later you want to upgrade the kernel, and you just have to rebase that always. And that Zephyr changes, of course, but it has a very, very good abstraction layer, which prevents you from rewriting the application every time you change a sock or change some hardware component, right? And bare metal, that's just always the case. And yeah, that generally makes me very sad, because that's usually not fun maintaining like all these legacy components. So later, I decided, okay, let's do this with Zephyr, and we are still not upstreaming enough in Blik, although we do. So I can't stress this enough. Like, by upstreaming, you get so much exposure to freelancers, which can help you in development. Like, we had a couple of freelancers engaged in our projects. That just helps you get the project going, because in startups you're generally resource constrained, right? You want to have someone helping you with this, and upstreaming is just the way to go, at least from my opinion now. For example, we have some flash drivers that we currently still maintain ourselves internally, and which is at the moment actually the biggest pool of conflict if you want to upgrade to a new kernel. On the other hand, we made some changes to the network stack, because currently we're not really able to use the Zephyr network stack due to some constraints, and that is also not yet upstreamed. I'm in the progress of engaging discussions there, but what Zephyr then actually enabled us to do very fast is actually adapt the network stack very easily. So we just introduced our own radio API, and we were able to use that in the application. That was very fast. It took me like 1 or 2 weeks, and then we were ready to go, and without any hassle and some sort of conformity in the project that's not very, that's not a heavy technical debt. Of course, using off-the-shelf components where possible, for example, like a serializer, for example, that we wrote ourselves. We don't do that anymore, just use an off-the-shelf serializer, and it's very easy with Zephyr to integrate these external libraries into the build system. Like, for example, protobuf, if you want to use that, it's very easy. Zephyr uses CMake, and if you find a library that also is built already with CMake, it's very easy to get these integrated as a submodule in your project, and just integrate it in your build system, and you're done. Also, shell access, for example, for testing and debugging. If you know, like, you don't just build the features, but also testing components. For example, end-of-line testing or compliance testing for CE, for example, requires you to test certain functionality on the device, and just to get some I/O on a serial port, for example, for the device, just use the shell of Zephyr. It helps you. You can hook your own functions in there and implement the testing, and the interface is already there. Just use that. So yeah, sticking together components with Zephyr is really simple due to its very coherent build system, in my opinion. And of course, the build process. If you're talking about CI and embedded, there's actually not too many options that are very out of the box. For example, testing without actually mocking a sensor or an interface, for example. But at least the build process is very easy to implement in a CI, and you at least want to have that before you merge something from a merge request. Yep, makes me happy. Generally using Zephyr for these types of projects, especially in fast-paced environments, makes me smile. So, as you saw, most of my experience came from startups, and as I also already mentioned, startups care about features. Like, it's about sales. Like, you have these big goals. Everything that's touchy and shiny, you can sell, right? So, actually, everything that you can tell to a business guy, okay, I'm working on that and that and that, and he can actually try it out. That's very, very nice, and everyone sees, oh yeah, you're working on stuff. But that's not always the case, right? So what you do is you work in a very fast environment, so prototypes, iterations, and fast to market. But you have to, as I mentioned, implement the build system, the board support, tests for production environment, and that's not very flashy. You cannot show that to a sales guy and tell them, hey, tell that to the customer. We can do that. Like, no one cares. And this makes progress feel very slow for these people, and it makes it very hard for you to justify the resources you need for development. And this is why you actually want to have something to work with that takes off a lot of work from your development process, especially in low resource environments. So since your backlog is always growing and you want to implement features and your resource constraints, you want something that takes off this general load around it, and you can actually, at least to some bigger degree as usual, focus on these features. And for that, what you want is a solid build system. You want to have a solid architecture or at least something that gives you already the framework of a solid architecture, so you can orient yourselves along that. These like interfaces, serial interfaces, radio interfaces, networking, anything you can think of. And the ecosystem, of course, because you want to have people to talk to if you have problems, right? So if you use if you build your own bare metal application, you can't ask anyone, right? You're probably, even worse, you're dependent on this one developer that developed the kernel, but he left last week. That sucks. So community is very important, and standards are very important. Like, most likely, for example, in the case of Zephyr, there's already libraries supported like MQTT, co-op. If you want to use that, you don't have to worry about implementing that in your build system or general development. You can just tell an intern, hey, prototype that for me, and he will be able to do that because the documentation is actually very good, and there's a lot of samples already. Or Bluetooth, like you won't have any problems getting a Bluetooth application running with a dev board that's already supported. This brings us generally to the RTOS choice. It influences actually your roadmap because you have to think about all these things that you want to develop, set up, and maintain around your project. You want to use something that gives you all the components that you actually want to use in that regard. And there's a couple of RTOSs, of course. We of course looked into them, like Embed OS, Contiki, FreeRTOS, right? Maybe if you're okay with the license, especially. And in our case, we decided for Zephyr because it actually applied very well to all these requirements, in my opinion, for where you have to work on hardware support, the tool chain, all the testing that you want to do. These APIs and interfaces that you actually need for any IoT application in that regard. Drivers you need for your sensors or radios, application libraries like I mentioned, MQTT and so on. And especially the license, because you want to be able to make modifications to the kernel and actually maybe don't want to publish them, even though I think upstreaming is the better option. But sometimes you don't always want to publish them because you want to prototype first and ship a prototype to a customer. And you want to be compliant with the license, right? And with Zephyr, that's really easy. In my opinion, Zephyr falls very well in all these requirements. So it's a very nice code style. So it's very easy to actually read a driver or implement anything that's implemented in Zephyr and look around and find your way around the code. It's very easy to get used to that and very easy to adapt it. And the documentation is very nice because as far as I worked with Zephyr, there's really nothing that's not really documented. So that you find something for everything. And generally, the API documentation is very well because, if I'm not mistaken, it's exported from the Doxygen comments. And yep. On the other hand, it helped me ship products fast, right? So 6 months from prototype to CE, want to see that somewhere else. If you have a pile of requirements and want to build something from scratch, yeah, not easy. Especially people forget about prototyping, production and testing, right? So it's not just about this. Yeah, how difficult can it be to send a packet to another device, a second device, just a receiver? I just want to do that. Yeah, but eventually, especially if you work in industry, you want to be able to certify that product, and you need to go through testing and end-of-line testing and certification. And yeah, features is not everything you're going to be working on. I was able to maintain all these projects with relatively few people. So onboarding always was very fast, even though it was painful, of course. If you're in a release window, onboarding someone is not really fun. But it was easy because you could just pinpoint them to the documentation. And also with freelancers. In the beginning, like when I worked at ProGlove, it was Zephyr 1.6, I think, when we started working with Zephyr. It was not easy to find freelancers, but anyway, the freelancers we found were very easily able to work their way through it and then actually contribute something we could really use in the product. And Zephyr's community is very welcoming. Like from my point of view, if you're chatting in an IRC, just asking a question, there will be definitely someone who answers your question, which is necessary because you don't want to be roadblocked by something like that. And upstreaming is also very direct. Like we upstreamed a real-time clock driver for one of our SOCs, and it was very easy. We found a freelancer who was already involved in Zephyr, so it was even better. And yeah. Usually people are there even from the chip vendors like NXP or Nordic, where the board support, for example, is already very good. So if you want to prototype something, just use these boards, and they work out of the box usually for most of the common applications like Bluetooth or 15.4. And if you have questions about that, you're very easily able to contact these persons because they're generally maintainers of an open source project. Yeah. So in my opinion and in my experience, what I have right now, even today, is that they're very forthcoming and friendly towards you. If you just ask them, hey, why does this driver work? How does this work? Do you know someone who can help me with that? So yeah, very nice. And of course, also something that comes with upstreaming is it gives you more reviews, right? So during our upstreaming from the real-time clock driver, for example, we had more eyes than just our own to review that. And what we benefited from that is actually okay, our driver was better afterwards, and it integrated better with Zephyr, right? So and this gives us more experience with working with Zephyr, and later on being able to better upstream. And in general, raising the quality of the real-time operating system and eventually your own product, right? And your own flexibility in upgrading later or changing something. And yeah, at last, I want to thank everyone who worked with me up until now and today, and everyone who gave feedback to the talk. And I think it's time for questions. Yes. Yes, so I think this heavily depends on your, maybe I repeat the question. So what was most painful with Zephyr? Because I mentioned a lot of advantages. So one disadvantage, for example, is the network stack. So currently it supports IP. And with IP, I think you can do a lot of things. But if you, for example, in our case, want to interface directly with the radio or directly with layer 2, that's not possible. So there, and then on the other hand, it was very easy to throw in our own interface, right? So if you want to work with the net stack, that's probably depending on what you really want to do with your product. On the other hand, for example, regarding low power management is something that's very use case specific. I talked to 1 or 2 developers some time ago, earlier this year, And there's not really low power management implemented. You have the hooks for it. So if you use the kernel goes to low power if it enters the idle thread. Still, you need to take care of yourself to actually shut down all the devices and all the sensors. And then again, there's tools for that that makes it very easy. For example, the drivers generally support a low power hook that you can also call in the subsuspend call. And I think in 1.13 there is now actually a template implementation of parts of that, if I'm correct. And that takes work. And then of course, depending on what type of low power management you actually need for your applications, and for example in our case the devices need to be essentially in low power all the time. So then there's the question, how do you use Zephyr at all? I mean, do you need threading? And how do you make sure the radio wakes up in a correct state and things like that? So you have to look into these things that then probably need some adaptations in the drivers, and then it also makes sense to upstream that in some cases. Yeah. Other than that, I think a lot of things have improved really. So back in 1.6, I think that was around the time when Zephyr actually went public 2 years ago. There were a lot of things that were, from a driver's point of view, not really implemented to 100%. Still, I think the peripheral support is very good, but sometimes you just need to implement another port or something like that. At the moment, I think the support for that is really good. Like in our case, we didn't really need to implement anything else in that regard. But back then, and especially if you use some SOC that's not yet supported or fully supported, then the advantage in that case would be you need to implement that. Yeah. Yes, very easy. There was a time, so 2 years ago, it was still all kconfig. They moved to DTS now, device tree, which needs some getting used to. But if you're used to DTS, it's very easy. And there might be some things you need to port to DTS yourself for your board. But in general, there's like a lot of support from the community. If you have questions about that, that's really straightforward. Like adding a custom board, for example, if you use a SOC that's already supported in a dev board, for example, you just copy that dev board and make your adaptations. It's very easy. Any more questions?
Yeah.
Yes, please.
So you said you started on Zephyr 1.6, so it's the very beginning of Zephyr. Weren't you afraid of seeing just so many changes happening at the same time that you were developing your product? And didn't that scare you?
No.
Okay.
So maybe to elaborate a bit on that, because and just no is funny, but the thing is, if you don't plan to upgrade, then because if you start developing the product based on a kernel like we do right now, it's a question of are you happy with the stability of the system? If yes, there's at first no need to upgrade, and later on actually upgrading. So at the time when at ProGlove, we updated from 1.6 to 1.9. It was actually very easy. The only thing we had to adapt was, I think, the SPI API that was rewritten. But other than that, and it was also a new product cycle, so we had the time. I mean, what means afraid? Maybe you can specify a little bit what you mean by afraid.
At the time, I'm not sure if the microkernel, nanokernel transition had already taken place, the kconfig had already taken place, and so many things you're doing your development, and you're going through that heavy amount of modifications. Is that going to be a problem for your application or not? Whereas it's interesting to see that you still decided to go with that, even at that early stage of the project.
I understand. Yeah. So generally, we always use the stable versions. Like the versions get tagged, and because Zephyr is developed in a way that you have, I think there's 3 release candidates always, and they get also patched during that time. And if that's tagged that's more or less stable, because there's also a stabilization phase for the release candidate before they finish the release. So in general, I would say I personally wouldn't be afraid of using a stable version. If you use a version that's just master, yeah, I wouldn't be so sure about that. Then I would be afraid, because there might be some components that still depend on a different API and something like that. So these might break things later on in the application or your own kernel adaptations. But generally, going with a stable version, I wouldn't be too afraid. Any more questions? Very well then. Thank you so much.